All right, cool.
Okay.
All right, cool. So I'm going to be talking about music, and then at a later point in time, we're going to be relating this to some mathematics. So something that I have always loved about music, and something that I find really interesting about it as an art form, is that it's an art form that's actually experienced in time, right? Which does make it a bit different to something like a painting or something like a sculpture. There's really like a duration of time in which the art piece is experienced. And what's really cool about that is that you can then play with it, right? You can then play with like the way that that time is felt and the way that it affects the mood and all that kind of stuff. And that's absolutely one of my favorite things about music. That's probably why I went into drums, because the drum kit is such a good instrument for changing the feel and the rhythm and the mood of the piece. So what I want to tell you about is how some musicians, at least, describe timing in music. I'm going to try and do this on the whiteboard, so check out the bottom left whiteboard. I'm going to do some very messy drawing at the moment. You've probably heard of the concept of tempo, and we've all seen that movie Whiplash where it's not quite like tempo, right? So if you've ever thought to yourself, man, I wonder what that actually means. Well, what we say is in music notation, you'll normally have this thing here, which is the tempo marking. Let me fill this in, because it's a solid circle, not a clear one. Clear ones have a different meaning. Okay, cool. So on your sheet music, you'll often see something like this, and this is just a random example. You'll see some kind of musical note is equal to some kind of number, and these things can come in different shapes and sizes. The thing on the left hand doesn't need to be a crotchet or a quarter note. They're also referred to as, it could be something else. And the right hand side doesn't have to be the number 160. It could be a whole bunch of different things. But the way that you read what I've written right here is that one of these things, so every time you see this thing on the left here written in your music, you hold that note for the duration of 160 F of a minute, right? So there's 160 of these within a minute, and that's what BPM stands for. It's beats per minute, right? So this piece would be done at 160 beats per minute. And then once you understand that, you can then look at the time signature of the piece, which is going to be actually telling you how you're feeling the pulse of each bar. And as an example, that might look something like this. So this is the time signature 3/4. So we describe it with two different numbers. Don't think about this as a fraction. It's not really 3/4. That's not going to be a helpful way of thinking about it. And in fact, I kind of thought about this, and I don't think I fully agree with even using a number for the second number. So these two numbers mean something. The top one has an easy interpretation. 3 here just means there's going to be 3 beats per bar. So let me write number. Sorry, bar looks pretty messy there. That just is the word bar. I'm hoping that you all know what a bar is, when you're listening to music and there's a clear repetition of some kind of cycle. It doesn't have to mean that the music is repeated, but there's some kind of like collection of notes together, which is feeling the bar. And then you have many bars that form a piece. And so 3/4 is telling you that you've got 3 beats per bar. And then you should ask me the question, like, what's a beat, right? So that's what the bottom number is telling you. It's telling you the types of beats that we have the top number of in each bar, right? So that's a bit confusing, but it becomes more intuitive once you have examples. So this, I'm just going to write, is the type of beat. Okay, and this is what I mean by like thinking about it as a number is not necessarily that helpful. So on the here I have the number 4, and that just means these things that I've drawn up the top, these crotchets, right? So that thing is sometimes also referred to as a quarter note. And I think it's because of this 4 on the bottom where that terminology comes from. It's not the other way around, because what they mean by a quarter note is it's a quarter of the length of a bar, right? But but that's only if the bar is written in 4/4. So that's actually a circular definition. So I just find that whole thing confusing. So I'll just think about this as 3 crotchets per bar, right? But then I could also half the length of a crotchet and make that a quaver, and then that would be written as 3/8, and that's when you get these really interesting signatures like 5/8, 7/8, etc., etc. Anyway, don't worry too much if you don't understand the bottom number. By far, the more important number is the top one. And that's where you kind of like hear musicians talk in this way. Like you might have heard a musician say something like, oh, this piece is in 4, right? Or, oh, this piece is in 3, or this piece is in 5, or this piece is in swing time, or this piece is in simple time, whatever. So they're all referring to the top number here, right? So let me give you some examples of this. I've got some pre-prepared music over here. So say I was talking about a piece that's just in 4, right? Now 4/4 is like a very, very standard, very, very common time signature. It's very marching. It's used in a lot of rock music, a lot of metal music, etc. And you'll hear the marching vibe of it in this piece sample that I have here. Okay, cool. So that was actually in 4/4. So yeah, a lot of my music, I really enjoy kind of playing with the signatures. So I'm not sure if this stuff is actually the best example anyway, but it's the music that I own. So let's just go with that. Just keeping my eye on the chat, I've noticed that Lucas reckons he can add to the discussion. Do you want to pipe up, Lucas?
Can anybody hear me?
Yep.
I can hear you. Yeah.
Oh, good. You can hear me. No, I just, you're flowing. I think you should just keep going.
Oh, okay. Sure thing. Yeah, it's all a bit rushed. I just want to keep this within the 20 minutes. Yeah, I think some people might have issues with some of the things I'm saying, like putting all the emphasis on the top number. Like 3/4 is meant to be felt very differently to 3, to like 6/4, even though they're kind of similar, etc. Whatever.
It's easier if you just think of it as, instead of the British convention of crotchets and quavers and breves and semi-breves, if you think of it in the American convention of a whole note, which is just one, a half note, which is 1, 2, and a quarter note. So the bottom refers to, like, if it's a 4, it refers to quarter notes. If it's a 2, it refers to half notes. And then the top number is just how many of those are in a bar.
Okay, sure. Yeah, so this is one of those things that you have the British system, the American system, and they love fighting over it. Anyway, let's give an example of a more swing time feel. So this would be like something in 3, but I'm just trying to think what the time signature of this one actually is. I think it's actually 6/4, but you can think about it as 6/8, or you can also think about it as 12/8. But try to feel like the swing to this. So this is meant to sound like da 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 da. Swing music is very easy to dance to. That's why if you go to like a Dorf or a nightclub, the music sounds like da 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 da. That's all in swing time. Okay, let's give this one a shot. Okay, cool. So yeah, I'm reading the comments again. We've got this comment that psytrance is neat because it sounds like triplets, but isn't. This is kind of interesting music writing, in my opinion. So have you ever heard the phrase, you've got to learn the rules to know how to break them? I think that a lot of musicians really enjoy that kind of vibe. So what I'm saying now is kind of the common practice period way of thinking about it. And this is what they'll teach you in piano lessons as a kid, etc. But the whole point is to kind of grow up and play around with it, as I already kind of mentioned. Like, you could say that the second sample I just showed you sounded very marching, and the first one sounded very dancey. Well, that's because I love turning these things on their head. But anyway, let's just move on. What I want to actually talk about is polymeters, right? So a really cool thing that you can do, it's very progressive. This gets used in a lot of progressive rock music, if you know the bands like Yes, or a modern example would be someone like Steven Wilson. and also lots of progressive metal, which is the kind of music that I absolutely love listening to. But there's other examples as well, modern jazz, etc. You don't necessarily have two different instrumentalists playing the same time signature at the same point in time, right? Like, you know, I might be playing with my guitarist friend and he's playing 3/4, but then I'm playing 4/4. And then what's neat about that is that's going to loop around every 12 bars, right? Because that's 3 times 4. So you can get some really nifty stuff like that. And then if you're a drummer, what's really cool is you're commanding multiple instruments at one point in time. And drums is an interesting instrument because you play it with all 4 of your limbs. And so you can actually play different time signatures with different limbs. And this is something called limb independence, and drummers will spend a huge amount of time working on this. Heavyweights of the sport are able to do more time signatures than you have limbs, right? So you get one limb doing 2 signatures, another limb doing 2, and then maybe the other 2 doing 1, and then you've got 6 signatures going with a single instrumentalist. It's all very cool stuff. Yeah, I'm seeing Dream Theater being dropped, I'm seeing Tool being dropped. These are all very good examples of what I'm talking about. Anyway, so I love polymeters. You can hear the following one, which is from a piece called Pedagogue. Now, this one is in 15/16, but I've got the hi-hat playing every single 4th note. So I'll think about this as the hi-hat is playing in 4/4, and it's playing every single beat, but the China cymbal is playing the first beat of every 15/16 bar. Okay, so one of them is playing every 15 notes, and one of them is playing 4 notes every 16 notes. So let's see if we can hear that. Okay, cool. I'm more than happy to show people some isolated drums there if anyone was interested in such a thing. Cool. So now to bring maths into this, well, I don't want to give away the challenges, but let me just casually refer to the Chinese Remainder Theorem, which Dan has very kindly drawn out for me on this bottom right whiteboard. So let me make this statement very clear. And this is the point in the talk where you'll be like, how on earth is this related? Well, that's kind of the point, and we'll come back to that later. But let me just make sure that everyone understands the statements and the group theory involved inside this theorem, right? Okay, so pay attention to the bottom right whiteboard. We've got these k integers, n1 up to nk, and we're not allowing any of them to be 0. Now, we're asking for this list to be pairwise coprime, right? So the greatest common divisor between ni and nj for all I not equal to j is 1, right? And then we're just going to define this new number, capital N, which is just going to be the product of these integers n1 through to nk. So that's literally just n1 times n2 times ... Okay, and the Chinese Remainder Theorem states that there is a ring isomorphism between z mod capital N and the product of all of these z mod n1, z mod n2, ... And the most interesting part of this theorem is injectivity, right? So if I have a sequence of integers on the right-hand side, then there is a unique number inside this z mod nz that when I look at it modulo all of the ni's, I get the numbers in that sequence that I started off with. And that's kind of what the original formation of Chinese Remainder Theorem was. But with the tools of modern algebra, we can state it a lot more neatly by just saying that this is a ring isomorphism. Does anyone have any questions about the terminology, about the statements, about anything to do with this? Now is your time to ask.
What's the inverse?
You're not meant to ask that. Any other questions? we'll be talking about the inverse later.
Sorry.
You're ready for the challenge.
Yes. But that's a good question, and we're going to be playing around with that a lot. Any other questions?
I'm not in the world, but what's the capital M?
Just the product of all of the coprime lowercase n's that you started off with. So you take a list of pairwise coprime integers, and then capital N is the product of all of those, right?
Well, thanks.
Okay, no worries. So very quickly, I've got 3 minutes left, and that's all the time that I need. I want to show you one last thing that I've prepared, but I need to actually go to the Discord now. So I'm going to go to the Discord and share my screen. So everyone go there and have a look. And chime into my stream. You have to click view stream or whatever it is. Can I just get some kind of survey of people once they're... Yeah,
I'm good.
some people logging on.
I'm watching.
Okay, I've got at least some people looking at it. Okay, cool. So what I want to show you here, and then you should have in the back of your minds how this relates to the Chinese Remainder Theorem, is I've got 3 instruments here. They're all parts of the drum kit. So the top one... I didn't label them. The bottom one's the bass drum, the middle one is the hi-hat, and then the top one's the snare drum. Yeah, I believe that's correct. And the top one is going to be playing every 7th note, but it starts on the 2nd beat. The middle one is going to be playing every 5th note, and the bottom one's going to be playing every 3rd note, right? So the numbers there were 7 and 5 and 3. And what I want you to pay attention to is the fact that when I play this, you'll hear that there is only one spot in this sequence where all 3 of the instruments play at the exact same time. So let's see if we can hear that.
I don't hear anything.
Are we not hearing anything?
I can hear
I
it.
can hear it.
Oh, okay. I'm the only one who's not hearing anything. That's odd.
Okay, cool. So I'm sure you've heard this a million times in your life, Lucas. This is just 3/5/7. So
No, I wouldn't say a million times.
Enough times. I'm sure you get the principle. Okay, cool. I'm not going to take any more time than that. So
All right. Thanks a lot, Will. Any quick questions?
Thanks, Will.